So section 9.4 begins on page 634. And what we're going to talk about today is the third of our conic sections, which is the ellipse. And so the way that we get an ellipse from slicing our conic is we start with our conic, our double cone. And what we're going to do is we are going to bring a plane in to slice one piece of the conic at an angle, though. Remember, if we came straight across perpendicular to the vertical axis, we got a circle. But by adjusting that and coming in at a little bit of an angle, as soon as the plane moves and the piece falls away, you guys will see that we basically get this oval shape. Okay, it's a little bit of a thick oval here just because of the way I had to construct the 3D models to make the video. But okay, everybody sees where that oval comes from? So we don't get a true circle, we get a slightly elongated circle. So that's the idea of where the ellipse comes from. The definition of an ellipse is the locus of points. And what does locus mean? Good. Of points in a plane such that the sum of the distances from two fixed points to any point on the locus is a constant. What does that mean? Well, we have two fixed points. And imagine me taking a loose piece of string and attaching it to those two fixed points. So one end gets attached to one point, one end gets attached to the other point. Now imagine that I take my pencil and I hook it under the string and I pull it taut. Okay, the string doesn't stretch, so I just pull it until the string is tight. So maybe I can pull it to right here. And so what I end up with is I end up with maybe something that looks like this. Okay? So the string is now straight here and here. Can everybody visualize that? Okay, so this would be one point that's on our ellipse. This is a distance, this is a distance. What we're saying is that d1 plus d2 is always going to be a constant. What I'm going to do now is I'm going to move my pencil everywhere that I'm allowed to move it, keeping the string taut. So maybe there's a point over here somewhere. Maybe there's a point over here somewhere where, again, distance 1 plus distance 2 is a constant. Why is that distance always a constant? It's the length of the string. Exactly right. Make sense, guys? The length of the string isn't changing. All that's changing is how you're divvying up the length of the string as distance 1 and distance 2. And so I slide my pencil along, and there's going to be points down here as well where distance 1 plus distance 2 is, again, the length of the string. So everybody gets the idea? Okay? Now, so those distances are d1 and d2. The two fixed points are called the foci. Again, the plural of focus is not focuses. That's the plural of focus when it's used as a verb. When you use focus as a noun, the plural is foci, F-O-C-I. So we have two different foci. The two fixed points are focus number 1 and focus number 2. And so when we drag our pencil everywhere that we can, keeping that distance the same, we end up with this oval shape, which is called an ellipse. So let me show you how we construct one of those. So here's our geometer sketch pad. If you take a look at this, I have my focus number 1 right here. I have my focus number 2 right here. This is my distance 1. This is my distance 2. Notice that distance 1 is listed as being from this point to this control point. And distance 2 is from the control point to the other end. Notice that from here to here is the length of the string. All we're doing is divvying up which part of that or portion of that distance is D1 and which one is D2. And by dragging that control point and divvying up D1 and D2, now I only have D1 and D2 being drawn above, but also there's another one being drawn below at the same time. What we end up with is we end up with our oval, our ellipse. It doesn't want to connect on that side for some reason, but you guys get the idea. There is our locus of points. Everybody see how that works? And we get a perfect ellipse. How do we change the shape of that ellipse? There's two ways to change the shape of the ellipse. One is to change the length of the string. What's the other one? Yeah, change the distance between the two foci. So for example, if I take this focus, actually I'll leave that there. Let me take this focus and let me move it over here. Now I still keep the same length of string, but notice now I get a longer, skinnier ellipse. Everybody see how that works? Also, I can change where the two foci are in relation to each other. So if I want, I can stack the foci this way. And now I get one that's stretched up and down. Everybody see how that works? And again, if I want, I can change the length of the string. If I change the length of the string, that's also going to have an effect on the ellipse that I get. So that's how we actually change the shape of our ellipse. Questions about that? Okay. So, when we have an ellipse, there are some particular parts of this ellipse that we are going to concern ourselves with. Actually, let me change the way I drew that. Let's go just from there to there. You have a long direction and a short direction. What an ellipse is, guys, is basically a circle that is being stretched more in one direction than the other. So imagine taking a circle and putting your hands on the left and the right side. So if you're thinking about a clock at 3 o'clock and 9 o'clock, right? One hand at 3, one hand at 9, and pull it in the x direction. That stretches it this way. We could also put our hands at 6 and 12 on the clock face and pull it up and down. So we have two different ways to stretch this circle. Okay? In any case, regardless of which way we stretch it, we get a long direction and we also get a short direction. The long direction, so I'll give you some names. So AB is called the major axis. That's the long direction. What do you think CD is called? The minor axis. Okay, we can also talk about what is referred to as the semi-major axis. What does semi mean? Like semicircle. What does it mean? Not diagonal. What does semi mean? Half. Semi means half, like semicircle. Okay? So you can also have the semi-major and semi-minor axis. The semi-major axis would be from here to here, from the center to either A or B. And the semi-minor axis would be from the center to either C or D. Does everybody see that? Okay, so this would be the semi-major and the semi-minor. And again, semi just means half. Okay. Any questions about that? Notice that there are 4 guide points on this ellipse, and they have special names. The ends of the major axis, regardless of whether it's going left and right or whether it's going up and down, makes no difference. The ends of the major axis are referred to as vertices. And so this is a vertex, and this is a vertex. The other two, the ones on the minor axis, are called the co-vertices. So this is a co-vertex, and this is a co-vertex. So we have two vertices, we have two co-vertices. Again, the vertices are not always going left and right. The vertices are always going in the long direction. The co-vertices are always going in the short direction. Okay, questions about that? Now, this semi-major axis, how far we go from the center, which I'll call E, to one of the vertices, we refer to this distance, the semi-major axis, as little a. And we refer to the semi-minor axis as little b. Okay? And you'll see where that comes into play in just a moment when we look at the equations. So this is just basically your working vocabulary for ellipses. Any questions about that? Okay, so let's look at the actual equations. So again, just like our other shapes, we're going to start with our center only at 0, 0. We're going to anchor this thing at the origin. And then after we learn ellipses and then hyperbolas, then we'll start to change that 0, 0 to other things. There are two different versions of ellipses. One version, let me get my ellipse going. One version is when it's stretched in this direction. One version is when it's stretched in this direction. When it's stretched in the x direction, right, it's being stretched left and right horizontally, the equation is x squared over a squared plus y squared over b squared equals 1. Okay? Everybody see that? The other one is going to be x squared over b squared plus y squared over a squared equals 1. The difference is that a is always larger than b. A is the long direction. So that means your a squared is always going to be the bigger number. Now notice, when the bigger number is under x, it gets stretched in which direction, x or y? X. When the bigger number is under y, which direction does it get stretched in? The y direction. Make sense? So remember that a is always larger than b on these. Okay, so let's take a look at an example here. Let's take a look at x squared over 9 plus y squared over 4 equals 1. First of all, notice, guys, what's on the right side of both versions of the equation? A 1. If it's not a 1, guess what you get to do first? Make it a 1. And how would you do that? If you had something like 2x squared plus y squared equals 8, what you would do is you would divide both sides by 8, and this would become x squared over 4 plus y squared over 8 equals 1. That's how you get a 1, is you divide by whatever's on the other side. So be on the lookout for that. A lot of times you're going to have to do that one step to get it into the proper form. But we don't have to worry about that on this problem. So remember that our center is going to be 0, 0. What is our a squared equal to here? Which is the bigger of the two numbers, 9 or 4? 9. So 9 is our a squared because it's the bigger number. So a squared equals 9, which makes a equal to what? Yeah. 3. A is a distance, guys, so it must be a positive number, but you can think of it as plus or minus 3. In other words, what a tells us is that from the center, we're going to go 3 units each way in the long direction. And since 9 goes with the x, we're going to go 3 each way in the x direction. Does everybody understand that? So there's no guesswork here. If the 9 is underneath the x squared, then you're going 3 each way in the x direction. What's our b squared here? What's b squared? 4, which makes b equal to 2. And that's going to be in which direction? Y. How do you know? Because it's underneath y, right? Simple enough. So this says we're going to go the square root of 9, which is 3 in the x direction each way, and the square root of 4 is 2 in the y direction each way. So now let's graph this thing. So we take our graph, our center's at 0, 0. I'm going to put a little x there. You can use a point if you prefer. We're going to go 3 each way in the x direction. We're going to go 2 each way in the y direction. And now we're just going to connect those with a nice smooth curve. Again, make sure you hit your 4 guide points. Make sure that you make a reasonable effort to make it look like an ellipse. Okay? That's all I require of you. Here is what we're going to get. Here we go. There's our ellipse. Any questions about graphing them? Do you guys see how easy that is? What would have happened if you had x squared over 4 plus y squared over 9 equals 1? What would have changed? You'd go up and down 3 and left and right in the x direction 2. And you get one that was stretched up and down instead. Does that make sense? Easy enough to graph? That's all there is to graphing these. Now, we're not done working with this, but that's all there is to graphing it. So are there any questions on graphing them? So remember that a squared is always the bigger of your two numbers. And regardless of whether it's a squared or b squared, the square root of the number underneath it tells you how far to go in the top letter's direction. Now, does that mean it's not important to understand which one is a squared and which one is b squared? No, it's very important, and I'll show you why in just a moment. So remember that the bigger number is always a, or a squared. Okay, going back to this picture, there's one thing I left off of here, and it's very important. What did I tell you guys was involved in actually constructing these things? It was involved in the definition of these things. The foci, very good. The foci, we have two foci here. The foci are always on the major axis. So somewhere on the major axis is a focus and a focus. Focus number 1, focus number 2. If it's being stretched this way, then which direction do the foci go? Up and down, right? In the y direction. So focus 1 and focus 2 would be this way. Does that make sense, guys? So remember that the foci are always in the major axis, the long direction. Never the minor axis direction. Okay? Now, it turns out that the distance from the center to a focus we call little c. Was there a little c in our equation? No, it was x squared over a squared plus y squared over b squared equals 1, or we could flip-flop the a squared and the b squared, right, depending on which way it's stretched. So the question is, where does c come into play if it's not in our original equation? And there is a secondary equation for c, and it looks like this. A squared minus b squared equals c squared. You need this separate equation to work with these. What does that almost look like? Pythagorean theorem, the only difference is what? Minus. Now remember, guys, that the original version of this was x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. Notice that either way, regardless of which version it is, what's in between the x squared term and the y squared term? A plus. What's in this Pythagorean theorem looking equation? A minus. What do you notice about that? What are they to each other? Opposites. Do you guys see that? Why am I explaining it that way? Well, our next shape is going to be hyperbolas. And guess what the difference is going to be? Well, guess what's going to be here? Minus, and guess what's then going to be here? Plus. So that's why I'm explaining it that way, guys. If you understand that when it's plus over here on ellipses, it's minus over here, then it's easier to remember than when it's minus that when it's minus over here in hyperbolas, it becomes plus over here. Okay, questions about that? Now, a good way I came up with for remembering that it's plus over here in the main equation is what do the major and minor axes make when we draw them in? A giant plus sign, right? So that may help you remember that on ellipses, you get a big plus. So there's a plus in the middle of the two terms, which gives us a minus there. So let's now find the foci. So there are a bunch of different things that they can ask us to find here. One of the things they're going to ask you to find is they could ask you to find the length of the major axis. The length of the major axis is how far it is from one vertex to the other. So how far is it altogether from here to here? 6. What about the minor axis? 4. What if they asked you for the semi-major axis? Well, if they asked you for the semi-major, then what would it have been? 3. And what would the semi-minor have been? Easy enough? We can just see that right off our picture. What are the coordinates of the vertices going to be? What are the coordinates of this vertex here? Negative 3, 0. What about the other vertex? 3, 0. You can write that as negative 3, 0 and 3, 0. Or if you want, you can just write it as plus or minus 3, 0. Isn't that the same thing? Just both at once? It's up to you. I don't care which of those two ways you write it. What are the co-vertices going to be? Nope. 0, plus or minus 2, right? It's the y-coordinate that's 2 or negative 2. Everybody see that? Easy enough? Do you guys see how we can just get those right off of our picture? The only thing we can't get right off of our picture are the foci. Is everybody okay with all of this before I go through the foci? Okay, so what I want to do now is I want to talk about the foci. And I want you to do this a particular way. For the foci, I want you guys to make a big parentheses and put a 0 as both coordinates. But notice how I left space after each of those zeros. The reason I left space is we are going to add and subtract whatever C is after one of those zeros. We just don't know which 0 it is yet. Now, I'm showing it to you this way so that when we start moving these things away from 0, 0, you guys already know the right way to do this. So even though you don't have to do it this way now, you will need to do it this way later or you're going to get yourself into trouble. So I want you to practice the right way now. Why did I start with 0, 0? Those are the coordinates of what? The center. So later on, when our center is not 0, 0, let's say our center is 1, negative 3, then what you're going to do is you're going to start with a 1 and a negative 3, and then we're going to add and subtract C from one of those two coordinates. And that's how we're going to find the foci later on. Does that make sense to everybody? So please get in the habit of doing it this way now. It will make your life so much easier later on. Those of you that ignore me and just write the foci the quick and easy way on this section are going to have trouble later on in the chapter. Okay, I see it every year, guys. Please do it this way. It'll make more sense. Okay, question is, what is C? Well, we know that a squared minus b squared is equal to c squared. We know that our a squared was 9 and our b squared was 4. This is why it matters which one is a and which one is b. Because 9 minus 4 and 4 minus 9 are not the same answer. So remember that a squared is the bigger one. So we get 9 minus 4 equals c squared, which makes c squared equal to 5. That makes c equal to what? Square root of 5. So that tells us that to get from the center to a focus, we're going to add square root of 5, and we're going to subtract square root of 5 from the center. Now here's the question, guys. Which way are my foci going, left and right or up and down? Left and right. Which direction is that, x or y? So somewhere in here, it doesn't matter where, just put a little f. Just so you remind yourself which way the foci go. So, we said that the foci are going in the x direction. So am I going to add and subtract the square root of 5 from the x coordinate or the y coordinate? How do I move to where the foci are? Do I have to add and subtract to the x coordinate or add or subtract to the y coordinate? The x coordinate. And so what we do is this. Now, what does that simplify down to? What does this become? What is 0 plus or minus rad 5 really? So those are your foci. Plus or minus rad 5 comma 0. Is it always going to be plus or minus something comma 0 or 0 comma plus or minus something? Yes, when the center is at 0, 0. But again, if the center was at 1, negative 3, this would now be 1 plus or minus square root of 5 comma negative 3. So again, what I'm doing is I'm showing you the way to do it so that we can do it the same way regardless of where the center is. So you don't have to learn two different ways of doing it. Because it's not two different ways. It's the same way. So I want you to think about it that way. Questions about that? So we have our foci, we have our major or semi-major, minor and semi-minor axes, the vertices, the co-vertices. Any questions about that before we do one more example? So let's go through one solid example without having to do all the explanation in between. So let's look at one that looks like x squared over 4 plus y squared over 16 equals 1. Okay? Which way is this one being stretched? In the x direction or the y direction? The y direction. This one's going to look like this, right? Because the bigger number is under y. What's our a squared here? Nope. I'm sorry, yes. 16, which makes a equal to what? 4. And which direction is that in? X or y? That's the y direction, right? What's our b squared? Which makes b equal to 2. And that's in which direction? That's in the x direction because 4 was underneath the x. 16 was underneath the y. So that's the y direction. So let's graph this. The graphing is by far the easiest part. We start with our center at 0, 0. We go 4 each way in the y direction. We go 2 each way in the x direction. And then we draw our ellipse. Oops. Everybody with me on that? So there's our ellipse. Our center. Notice, guys, I don't use C for center. Why not? That's the distance to the focus, right? We're already using C. So call it the center. Our center is 0, 0. What are the vertices going to be? What is this vertex? 0, 4. What's the other one? Yeah, 0 plus or minus 4, right? Or you could write it as 0, comma 4 and 0, comma negative 4. It's fine to write them separately. What are the co-vertices going to be? Yeah, plus or minus 2, comma 0, exactly. Not 0, comma plus or minus 2, right? Remember, the x coordinate is plus or minus 2. The y coordinate is 0. Okay? We could do the major. What's the major axis? 8. What's the minor axis? What's the semi-major? What's the semi-minor? So those are all easy. You could fill those in if they ask you for them. But we want to do the foci. So what do we start with? What do we start with for the foci? 0, 0, right? And leave some space. Where are the foci going to go? Well, actually, let's do the equation first. So c squared equals a squared minus b squared. which is equal to 16 minus 4, which is equal to 12. So c is equal to the square root of 12. What does that simplify down to? 2 square root of 3, right? So the question is, do I add and subtract that from x, or do I add and subtract it from y? Well, where are the foci going to go? Left and right or up and down? Up and down. So as I go from the center to a focus, which coordinate is changing, x or y? Y. And so we have to add and subtract 2 square root of 3 from y, which means that our foci are going to be 0, comma, plus or minus 2 square root of 3. Because 0 plus or minus 2 square root of 3 simplifies down to just plus or minus 2 square root of 3. Randy? C is the distance from the center to a focus. This is C. And this is C. From the tells you where the foci go. Tells us where the foci are situated on the graph. Because remember, that's really what's describing the shape of the ellipse, is where those foci are. Remember, when we change those foci relative to each other, it changed the shape of the ellipse. Right. Well, that's where the string is anchored at both ends, is the foci. Exactly. Right. Does that make sense then? Okay. Other questions about that, guys? Does everybody see how that works? So please, when you're doing the foci, start with your center 0, 0, and then figure out where you add and subtract c from. If the foci are up and down, you're adding and subtracting from y. If the foci are left and right, you're adding or subtracting from x. And that will help you make life easy when we're no longer at 0, 0. It'll work the same way. Just you won't have 0, 0. You'll have other numbers there. Any questions about any of that? Okay, let me get you the assignment.